Sergiu Pasca is one of our amazing young breakthrough scientists. One aspect of Sergiu's work that I think is so phenomenal is that he's so focused on discovering the causes of autism, which is a worldwide problem, increasing in prevalence, increasing in detection, but in absolute numbers, the number of children with autism is just grown so much. And Sergiu's work is really beginning to get at the basis of autism in a way that we've never been able to understand before.
I actually did not start by being fascinated by neuroscience or by brain sciences. My encounter during medical school with one of my first patients with autism is really what made a difference. You know, seeing the struggles of the parents on one side and just seeing how complex and, you know, puzzling this disorder really was is what sort of like what drew me towards the brain first, and then brain disorders sort of like broadly.
Violet's 9 years old, and she has a genetic condition that causes autism and epilepsy. Violet was born completely healthy, was meeting all of her milestones, and then one night she was making a weird sound in her crib, and we went over to her crib and she was blue, and there were bubbles coming out of her mouth, and we called 911 and we realized that it was a seizure, and they just continued. From that point, she's been a different child ever since than the child that we knew. Probably, you know, the most she's ever had, probably like 60 seizures in a day. And at one point, she was doing that weekly. When Violet seizes, she also stops breathing. And if it's been a minute or two, she's blue and she hasn't been breathing for 2 minutes. So we carry oxygen wherever we go. She has learning difficulties, memory difficulties. It's been very difficult for just watching her suffer. I mean, she does suffer a lot.
One limitation to approaching the human brain and really understanding how it develops has to do with our lack of direct access to functional human brain tissue from patients. In studying cancer, you just essentially go and take a piece of tissue. You bring it into the lab, you put it in a dish, and you try to see what goes wrong and try to find ways of stopping that growth. We can't just do that for studying human brain disorders. We've been lucky to recruit Violet in our studies and harvest skin cells from her. And take those skin cells into the lab and turn them into stem cells. And stem cells have this amazing ability to turn into any other cell type. So of course we guide them to become brain cells. And we've been developing technology in the last few years to really take those stem cells and develop a three-dimensional living brain tissue from patients in a dish. You can actually see them by eye. They grow up to 4 or 5 millimeters in size. Essentially, they're like three-dimensional structures resembling the human brain that are derived non-invasively from a specific patient.
It's something I would never think was possible, or to create like a mini brain. Like how, that's something like out of a movie is the way that I would describe it, because that's the only way that it makes sense to me.
This is a tool that the scientific community can really use to derive human brain tissue from patients and ask questions about how the brain assembles itself and how then different brain regions talk to each other in a non-invasive way.
When your child is suffering and you don't know what's going to happen and if they're going to make it, you picture these people working really hard, with the lab coat thing, but really we do think that, like, there's these smart minds working on helping our kids, and that's sometimes all you have to hold on to. I don't know, you know, what's going to happen to my daughter tomorrow. But I know that I don't want another parent to watch their child suffer this way. Sorry. So yeah, it's really important to me to help other people so that in the future they don't have to suffer the way that my daughter does.